Welcome back, Precalcsters. Today we're going to continue on. We are still in Chapter 2, Section 6, and we are looking at rational inequalities. Now, yesterday we kind of did this in a roundabout way, and that's okay. When we look at it today, we're going to work another one, but I want it to be much more focused. You guys were fantastic about helping me find all this key information, but you agree it's not super organized right now. Now, the goal today is to clean that up a little bit. But the weird part about it is the order in which you do stuff in doesn't really matter, realistically. We need all of this information to be able to get it, and we're going to practice with this. And I'm going to give us a little bit of guidance along the way. Maybe there's some things that I recommend we do initially or not. But let's just jump in right away, and we're going to see example B. Now, for this, if you want a detailed list, I can give you this lovely 7-step process, but we're going to do the same thing every single problem. I'll put it up there at the end. Let's do one more together. I want to make sure we do a different function. Okay. For B, I want us to graph together g of x this time, and we'll say g of x is the lovely function 3x divided by x squared plus x minus 2. Okay. Now, yesterday, when we went through this, I just asked you guys for some key features, and they came out, and we had every single one of them, but the order was a little bit off. You do not have to do any specific order, with the exception, I'm going to write the order here just in case you want it. If you just want to write the single word of like, we need all this stuff, that will suffice all the same. So let's check it out. When we go through this, yesterday's problem, we had some holes in it that we had to go back and cross stuff off, right? Because we saw after the fact. We can avoid that entirely if we do something first. What about yesterday's problem? Here's where we realized it had holes. And how do I go from this step to this step? What did you say I would have done? I factored or I simplified, right? So I would suggest that when we're actually running through this, the first thing that we should do is just simplify. Now this entails factoring, but that's a good first step. So let's knock that one out real quick. I'm going to write the steps here as concisely as possible, and I'll do all the actual work over here to say that maybe it's not that bad. So right off the bat, g of x, can I simplify the numerator at all? No, it doesn't factor nothing. The denominator does, and I want you guys to factor the denominator for me real quick. If you struggle with it, which is okay, don't just wait for me to write it on the board. If you're struggling already, please let me know and I'll come help you make sure we can get the factoring taken care of. Now I'm going to run through the list in case somebody needs it, because if you're not done yet, we can clean it up. First thing, only looking at the denominator right now. There's no GCF. Done. Is it a binomial? No. Is it a trinomial? Just the denominator. I think so. What's special about that trinomial in the denominator? The leading coefficient is 1. That tells me what happens. Okay, I know there's like 4 or 5 people who already have the answer because you wrote it on your page. Why do I care the leading coefficient's 1? Shortcut. Okay. Factors of -2 that add up to 1 is all we're after. What are they? -1 and 2. So here we go. X minus 1, x plus 2. Does anything divide out? No. If it had, what would we have identified? It would have been a hole. Now, for that, there's no order really truly necessary for this. Legitimately, I think if we just simplify right off from the get-go, the rest of this problem comes really, really easy. So you don't need these in this exact order. Again, I just want to stress. But if you're just running through, maybe these are easy things to work out. What else we need to check for? Just so we have a detailed list. Intercepts. What kind? Which one? So let's find intercepts. Okay. So we'll just say step 2 is the intercepts. Now I'm going to make another little comment here in case somebody's struggling. Zeros of what give me the x-intercept? Good. N equals x-intercept. Okay, How do you find the y-intercept?
You set it equal to 0, f of 0.
So good. Evaluate g of 0. Because when x is 0, you must be on the y-axis. So let's get this out here real quick. Instead of the x-intercepts, or zeros, I'm just going to use the word roots of this. The roots, what's the only value of x that makes my numerator equal to 0? For this particular problem.
0.
We just set 3x equal to 0, and there's only one of them. It's x equals 0. Now, another additional comment that I might make, I definitely will think it, I might physically write it, I wouldn't normally really. This shows up how many times as a root? And 1 is an odd number or an even number? So what do I know the graph does here? It crosses. I'm just using that multiplicity to make sense of this. I think about this every time. I don't always actually write it. Okay, if I want the y-intercept, and I think that's the red I'm using, the y-intercept, we simply need to evaluate g of what value? 0. So let's see, that would be 3 times 0 is, I'll just plug it all in, over 0 squared plus 0 minus 2. What does this come out to be? 0. Which means our y-intercept as an ordered pair is where?
0.
So it's at the ordered pair 0, 0. It's right at the origin. Okay, cool. What other things did we possibly find yesterday that we were worried about?
Asymptotes.
Let's find some asymptotes. So step 3, I'm just going to call them the vertical asymptotes. And this happens where? How do we find vertical asymptotes?
Set the denominator equals 0.
Good. Zeros of d of x, or zeros of the denominator d. I'm going to write d of x here. Now, here's the other thing that we didn't do yesterday initially, but it's a huge time saver. This factorization is not super hard to get to. Right now, just looking at it, can you tell me what values of x on this problem make the denominator 0?
1 and -2.
We already have them, right? Here's my factors. Just set this equal to 0. X would have to be 1 or -2. So we'll just go ahead and say that. Vertical asymptotes. And I want you to be very, very specific with this. If it's a vertical asymptote, is it a y equals or an x equals? X. You have to have this. X equals, and I see 2 of them. This factor would be a 1 if we set it equal to 0. This is a -2. I need to see the x equals for this. Cool. What else could I find? Hey, let's check about the horizontal asymptotes. HA. This happens. How do we determine that? Now this was the bell ringer, and I'm going to try to be concise with this. Degree comparison. Where I'm not being really wordy about this because there's 3 possibilities that we have to worry about. They're equal, 1 bigger, right? Those are the possibilities. In this situation, it can be hard to look at this one and be really sure of that. My follow-up comment is check the original. Now, the non-factored version, because it's much easier to see, I can tell that this is a quadratic in the denominator, but I assume you guys can as well. But it's certainly easy to see that here. What's the degree of the numerator?
1.
So numerator, there's a 1 right here. What's the degree of the denominator?
2.
2. So the horizontal asymptote, let's see, the denominator was smaller, or the denominator was larger. What does that mean? Y equals 0. And I'll go ahead and do the same thing. The degree of d was equal to 2. And the degree of the numerator n was equal to 1. That's what we're using to come to that conclusion. So we have the roots, we have the y-intercept, we have the vertical asymptote, we have the horizontal asymptote. Any others? Say it again? The graph. So I agree with you. There's really no more specific key information. This last one is entirely dependent on how specific the directions are. If I just tell you to sketch roughly, this will suffice. This covers everything. If you wanted a better graph, you just simply need more points, right? So this one I'm going to say is step 5, but it depends. I'll say plot additional points as needed. And I'm just going to say plot additional points is really all that I'm going to say there. Now, depending on the directions entirely. Okay, this order will not always be the same for me, with the exception of the first thing I'm always going to do is simplify, because I want to see if stuff falls out. I didn't write it, but this is that beware if it falls out, there was a hole in your graph. Okay, so here's my challenge for you guys. We have all of this information. I want you to attempt to graph this function just using this info. I'm going to give you guys a head start. I'm not going to graph it perfectly, but what I can see here is I need to go at least there. Can you tell me, and I'll wait. I lied. I'm going to let you guys go. We'll come together in just a moment. Sketch it lightly so that if you have to erase stuff, that's a possibility. But try it, and I'll see what you come up with. Here we are. I don't need any of those steps. I just need this stuff. Okay. Right off the bat, is there any ordered pair you guarantee I can put on? So 0, and it happens to be the y-intercept as well, unfortunately or fortunately. So here we go. I'm going to use this lovely red color. Here's 0, 0. Notice I have not committed to any scale yet. Okay, looking at this, the order actually comes out about the same that I would actually do stuff. I'm going to switch colors here and go back to black. On my scale, how far out in either direction do I have to go? So at least a 2, because I want to go past this. So we'll go 1, 2, and maybe the beginning of 3. Okay, in the left, I need to at least go to how far?
2.
So always one more, at least to -3. Now if you want to go all the way out to -10 and just draw a huge one, that's fine. But I want to make sure that I can see both sides of the asymptote. Okay, do I have any y values that tell me what the scale needs to be? No. And maybe that's okay. We'll get there. If we're just sketching, depending on how specific we want to be, we might add a y value. But I'm going to switch colors. Now I'm going to make a dash line, and I have to use some fancy erasing for that. Where am I going to put dash lines on this graph? So here's x equals 1. And I'm actually just going to use this solid pink line because I can tell the difference, but you guys should dash them on yours if you're not using a different color. This is a vertical asymptote. Can we touch it?
No.
No, bless you. Don't touch it. Don't even think about touching it. Okay, -2 is the other one. Can we touch this one?
No.
No, don't you even think about it. Any other asymptotes we should draw? Oh my gosh, I am really struggling here. Okay, perfect. The horizontal one is always weird. I would draw, it's the y-axis, right, or the x-axis. When I draw mine, I always just go a little bit above it so it looks a little bit more bold, especially when I'm using pen or pencil. There's my horizontal asymptote. Can I touch it? Yes. The horizontal one we can touch. Not at infinity, but we can touch it in the middle. Now, very clearly, I'm touching it right here, and I can see, I must be allowed to touch it because it's already on. Okay. Now, we don't know what happens on the side of this, except I know that it crosses right here. Now, there's several options. I guess there's 2 options. Don't commit to drawing these yet, but if I know it crosses here, and it goes from positive to negative, it means it either does something like this, once it hits, it does something like this, or it does something like this. Those are the only 2 options. How are we going to decide which one it is? Yeah, let's check. We can either check f of or g of, in this case, 0.5, 0.75, 0.1, -1. Any options? Let's try -1. Now, we are going to do a little bit of scratch work, and I'll just go ahead and say, here's my step 5, a few extra points, because we only need a very few of them. Extra points. Okay, at g of -1, there's 2 ways that we could evaluate this, and there's really more than 2, but we could plug -1 in here. And it's not terribly hard to do. Alternatively, 100% of the time, I would rather plug it into an easier form of g of x. This one's fine. What's the other form? The factored form. I can plug it into this one. These are the same. They're equivalent. We're going to get the same answer. I'm going to plug it into the factored form since that's one that I see. So I know that g of -1 is, and tell me if I'm going too fast here, -3 in the numerator. Because I'm just plugging in a -1 for x. Over, let's see, that's a -4. because negative 3 minus 1 is a negative 4, and negative 3 plus 2 is a negative 1. Okay, now the number is not really the important part. I get negative 3 over 4, and I get an answer out of this. Now, since we have the y value more than, am I wrong?
Isn't it supposed to? You plugged in negative 3 instead of negative 1.
I certainly plugged in negative 3 instead of negative 1. Thank you. The negative 3 up here is correct. So that's good. Negative 1 minus 1 is negative 2. Sorry. And negative 1 plus 2 is a positive 1. So I think I get negative 3 over negative 2. Does that seem better? Which, negative over a negative? 3 halves. Now, if you want to take the time to do this and get a value out of it, I think it's pretty reasonable. I could put 1 and 2 right here, and 3 halves is halfway through it, right? Okay, if you don't want to, all I care about is this positive, you're going to get the same basic graph. It might look a little different, but I know at negative 1, we were up to 3 halves. So all of a sudden I have this point. With this middle section, do I now have enough to decide whether it was this one or this one?
Yes.
For sure, it has to be that first one. Now, how close you get and how fast isn't super important as long as I can tell it's getting closer. This one, I haven't looked at the rest of the graph, but I know it, my hand skipped. And it comes down to here, then it comes down through here, then it turns. Okay, big warning real quick. You guys are going to be able to tell what's wrong with this immediately, but I want you to tell me how you think I deal with this with grading.
It's going past the point.
You've lost your points on your graph. I'm crazy with the asymptotes. Don't even look at them. Okay. Hopefully you can tell I'm trying to sound threatening and menacing, which is very natural for me. All right. No funny. All right. Deal. Well, I have the middle section all knocked out. We cool. I need the far out sections as well. Now, there's a bunch of combinations here. Could they both be above like this? So I guess rather like this. They could be there and here, right? Like it could be that. Could it be both down? Could it be one up and one down, or one down and one up? It could be. Maybe there's some other stuff that we could use, like even and odd functions to make sense of that a little easier. Or we can just get the sign of stuff. Pick something in this leftmost interval. Okay, negative 3, I agree with you. And this one is a 2 maybe. I want you guys, don't care about actual value. You're going to give me 2 more, at least, signs. I want you to do g of negative 3, and I want you to do g of 2. And if you give me the number, awesome. But all I care really and truly about is it positive or negative? Because that'll dictate, is it above or below? So I'll give you guys a second. Get me the value, or at least the sign, of those. Yes, Miss?
The 4, write it down.
Yeah. Sorry about that. And I can't see my function anymore, so I'm going to scroll up just a skosh. Do you guys get g of negative 3 as negative something?
Yes.
I don't know the number, but it's negative something.
You just plug in like any G.
On these last extra points?
Yeah.
So how I'm picking these is on our graph, and you have it. So there's very clearly this range of x, this range, and this range. Anything in this range is all mapped now. So negative 3 is the easiest choice. Couldn't tell. Let's take a look.
Okay, I think I really.
Where were you trying to put it in?
I was gonna do this one.
And that's okay. Like, we can do that. I don't know that I agree that it's easier, but if we do negative 3, we get a negative 9
Not on the other two.
over negative 3 squared is, so 9 minus 3 minus 2.
You got 9 fours. 9 minus 2, right? You got 9 fours.
So what?
9 fours.
So let's see, 9 minus,
Why is my brain not working?
no, and see, this is why I don't like this one, but we're doing negative 3, right? So we'll go to negative 9 over a 9 minus 3
Negative? Yeah.
minus 2.
Negative 9.
So negative 9 over 4,
So if it's
it's a
at the
negative
bottom,
over a
you got a
positive.
negative,
It's negative.
you're gonna know.
Now, I just want to show you here because I think this one's here
You know
for
it's
the
not
other one.
gonna
Let's
touch
use this.
on the.
Because you can certainly do it here,
You know it's not
but
gonna
check it out. You're gonna write a positive and
Since
negative.
there's no other.
3 times a positive is a
Can I ask you a question?
what?
What?
I'll ask you questions.
Yeah, sorry.
So look, I'm not trying to.
Okay, and there's 2 is we're checking, right?
You
So
know
2
it's
minus
not
1 is a,
Since we know it's
and
not touching.
2 plus 2. So you just told me it's a positive over a positive times positive. Is positive. Yeah. And they both give us the same value, but this one's way easier if all you care about is the sign. It might even be easier for the number realistically, but okay. So just to check, don't really care about numbers, and there's like 3 minutes of mute there for some reason. Do we agree that g of negative 3 is negative?
Yes.
It's negative, what's the actual number? 9/4. So that's 2.25. Okay. What about g of 2, positive or negative? Positive. Okay. What's the actual number? 3/2 again? Interesting. Or not. Maybe there's symmetry on the graph. I don't know. All right. Do you want me to actually use the numbers or just the signs? Okay. For the signs, and I'm going to pretend like I don't know the numbers. It's negative at negative 3. Okay. So all I know is that at negative 3, it's down here somewhere, even without a scale. But I'm just going to guess. I don't have a scale at all. Arbitrarily, I'll put it here. Didn't think about it at all. I just know it's negative. It's underneath the x-axis. Is it got to cross here? Like,
No.
because I mean, there are graphs where it could just do the same thing, right? Tangent or cotangent, rather, does exactly that. How do you know it's not going to cross over here?
You would have found another x-intercept.
There's no x-intercept over here to touch or turn. It can't. Which means, if it's never going to cross over again, its only option is from here to just get arbitrarily close. Do not cross it. This one I'm not as crazy about. Notice the tone is not as aggressive. You can cross these ones as long as it balances out toward this value at the end. Now here, same question. It is probably not going to do that. And in fact, I know it's not going to do that because why? Somebody other than Addison or Dolan, because they've answered a lot of questions today. Red, how do I know this graph doesn't do this? So I don't care about the horizontal asymptote because I can cross it.
It needs to get arbitrarily close to the vertical asymptote.
So why isn't this one doing exactly that? What would we have needed to find right here? There's an x-intercept. Did we find any others? So if there's no others that exist, it can't be there, which means if it can't turn up because it would have to cross an x-axis, which is the important part than the asymptote, Red, but you're not wrong with it. If it can't go up, it must go downward. Now, what did I do wrong? Yeah, I am terrible. Won't do that. We'll just get how close? Arbitrarily. Over here, you guys told me a second ago it was positive or negative?
Positive.
Positive. Don't know where, but we'll say it. Maybe it's here. Am I going to cross this x-axis again? No, I would have found roots, right? I would have found more x-intercepts. So if it can't cross, its only option is to stick up here and get close to that value. We have a lovely, or terrible, I don't know, graph in front of us. Is any single part of this like wildly difficult? I hope not. Like some of it should be kind of hard. Hopefully it's not really that bad for anybody. Is this easier or worse than graphing quadratics by making a bunch of points? I don't know the answer. That's subjective. Is it any easier or harder? There's more work for sure, but does it feel like the difficulty has really stepped up? I hope not. Should we check and see how close we are? We're going to. I don't know why I even asked. All right. I've already forgot the function, but no, I didn't. 3x divided by x squared plus x minus 2. There's the actual graph with actual good values. Are we close? We are so close to this. We can graph really complex functions just by making sense of what we have. All right, we have one more little thing. You want to do a quick brain break?
Sure.
Yes.
Okay, I need a question, or I'm going to get one of the awkward first aid questions. All right, so we did some graphs. Now, what types of asymptotes do we have? Vertical and horizontal. Now, out in the woodworks, I'm going to put on one more function up on the board for you real quick, and I want you to help me identify the asymptotes that we have. So, last little function, I want 3x squared, and you don't have to write this down yet, we're just going to look, over x. Okay, so is there a vertical asymptote?
Yes.
Yeah.
Can you guys tell me, without just looking at the graph, from this, can you tell me where the vertical asymptote is?
0.
It's at 0. What makes me divide by 0? It's 0. Okay, is there a horizontal asymptote based on the lovely equation that you guys see on the board? What's the degree of the numerator
2.
over the degree of the denominator?
1.
The numerator gets way bigger, way faster. There's no horizontal asymptotes. They increase or decrease without bound. Degree of the numerator is larger. That's what that rule tells us to do. Is there another asymptote that's here?
How do we find the vertical one?
Zeros of the denominator.
Oh yeah.
Now, for this one, very specifically, I'm just going to go ahead and graph one more line on this with this. Whoa. Well, hold on here. Oh, it doesn't touch it. But it does get, how close? Arbitrarily. So, last question, was there an asymptote? There's a vertical, there's no horizontal, but there's a diagonal. Now, we actually don't use the phrase diagonal. This one is pretty, I don't want to say rare, but we have vertical and horizontals. There's one more flavor of asymptote that we get to deal with. The last of these, last little piece, are our slant asymptotes. Okay, these are a very, very specific situation. I'm going to call these SA. Now, they're really called oblique asymptotes, which if you think about your oblique muscles, they're your abs that run like here. They're your obliques. They're slanted muscles in your body. That's the name. Oblique asymptote is the real name of these. Now, these ones, what we kind of just determined a little bit is that if we look at this and we look at the degrees, we're never ever going to have a horizontal asymptote and a slant asymptote. It's going to be one or the other. And there's a reason for that. What's the degree of this? Numerator, sorry. 2 and degree here.
1.
So the numerator is bigger. How much bigger? So by that I mean this is a degree 1 and a degree 2. It's exactly 1 bigger. Do you agree with that?
Yes.
So slant asymptotes rely on that little observation. We're going to say if the degree of n, the numerator, is exactly 1 larger than the degree of the denominator, then what does this symbol mean? The backward capital E. There exists. I'm okay if you use it. I'm okay if we just write the word. The backward capital E is there exists a slant asymptote or an oblique asymptote. I'm just going to use SA for this. At the quotient, and I say at y equals the quotient of n of x divided by d of x. Okay, there is a slant asymptote at the quotient of whatever we get when we divide these. Now I didn't write it, I'm going to let everybody keep writing, but there's warning signals going off right here. When we write this, notice, and I'm going to wait and let people keep writing and just check in. Still warning. Did I say the remainder? Did I mention the remainder? Don't use the remainder. It's only the quotient, only the very top part of it. Okay, with that in mind, never use the remainder. That is my little warning here. So let's check one out here. And we're going to do a quick example where I don't think I need to have you do the whole, you know what? We are going to do the whole thing. We're just going to say sketch. Now we're going to streamline this one much faster than the others because the slant is the only new thing I'm adding to it. But let's check it out. I want us to deal with only one of them this time. Let's say that our function is f of x equals, and we get x squared minus x minus 2 divided by x minus 1. Now, I will not be annotating this one near as much as the other one. We're going to work this together, at least up to the slant asymptote part. What's the first thing you guys would do? Don't divide yet. Like, I see where it's simplify. Okay, I just misheard. Okay, the denominator does not simplify any. Does the numerator?
Yeah.
How?
X minus 2, x plus 1.
X minus 2 and x plus 1. All over x minus 1. Did anything divide out? No. I was trying to see if it was starting to look like snow a little bit, because a minute ago it kind of did. It might just be blowing. Okay, so we're going to go much faster on this. I'm going to switch color just to see what we're doing. If I set each of these equal to 0, what did I just find? The zeros of the actual function are the x-intercepts. What values are those? X equals?
-1, 2.
-1 and 2. I recognize they both show up once, so in my head, I'm already thinking they cross. Okay, I'm using that idea of multiplicity. However, if it shows up an odd number of times. These both cross. If we set this equal to 0, I'm going to leave a little space here. What does that tell me? The 0 of the denominator. What is that giving me?
Vertical asymptote.
What do you guys think? Is that how we get vertical asymptotes? We try to make us divide by 0?
Yeah.
Cool. What is the vertical asymptote? X equals 1. I left some space here because pretty commonly we might find the y-intercept in this process as well. If I plug in f of 0, or yeah, are you going to plug it into the regular or factored form? Or does it matter? If we're trying to find f of 0, which one do you want to plug into, top or bottom? There's no right answer. I do think the top is easier. 0 minus 0, minus 2, over 0 minus 1. What's negative 2 over negative 1? 2. So 0 comma 2 is what we get. If we plug in a 0 here, it's negative 2 times 1, so a negative 2 over negative 1 is still 2. We get the same answer. I know that the y-intercept is at the point 0, 2. Okay. What's the degree of the numerator? 2, and degree of the denominator?
1.
So horizontal asymptote, if the numerator is bigger, what do we say? None.
None.
Okay, now if this is none, and is the degree here exactly 1 more? So we need to find then our slant asymptote. Decisions. We could do it synthetically. We could do it long dividing. It doesn't matter, I have a linear divisor. Thoughts? Synthetic. I'm cool with that. I'm going to do a little scratch work right here. There's enough room. What goes on the outside of my synthetic division?
1.
A 1. What occupies the top row?
1.
1x squared, negative 1x, negative 2, and how would one drop this? Like it's hot indeed. 1. 1 times 1 is 1, 0, 0. Okay, big moment here. What's my quotient? What's the remainder? Which one do I only care about for the slant asymptote? It's the line y equals x. Now, with just this information, we are pretty close to being able to graph it. I'm going to have a little bit of scratch to get 1 more point. I want you guys to graph this for me first. Try to. Put these pieces together like we did. I plot it, put your zeros, your asymptotes, and we'll meet back up in just a moment. I'm going to encourage you not to look at the board until you're done, because I'm going to try to do a little bit of it here. That might be too hard to do. I'll let you guys work for a minute. Okay, looking at this, I'm just going to pick a scale real quick. I know that I have to at least go out to -2, so I'll just show a couple ticks there. And I have to go out to at least +3, so I'll just put a few ticks there. And I might as well just call that 2, since I have it. Okay, so here we go. When I actually graph these, I'm going to go ahead and add this first. I will not touch this line. Now coincidentally, and I need to make sure that this works out because a slope of 1 is misleading on mine, there's the line y equals x, at least roughly. Now I know it looks a little flat, but it's because this is a distance of 1, and this is a distance of 1 right here. It's the scale's changed. Here's my asymptotes. Okay, now for this one, it's pretty nice as well. I know there's only 2 possibilities that really exist. It could do something like this, and this, or it could be this and this, and there's more combinations, right? We just need to decide which one it is, which I think is going to lock in the second I do this. I know that x equals -1 is a root. I've already committed. I know what it's going to look like on this side. X equals 2 is a root. Over here, I think that this is enough for me to confidently graph this. Now, this extra point is nice. It goes through 0, 2. These are the only 2 places it will ever cross or touch the x-axis. If it was positive there, it means it must have crossed over. So I know that this half of it must look like something like this, where it gets really close to that slant asymptote. This other side, it can't cross over the slant. It's not going to cross the x-axis again. So I think I can reason out that it must look something like this. And we now have our lovely graph. Okay, tonight I want you to get a start on this assignment. We have homework 2.5, which today is the 14th. Yeah, I already have it. Great. Okay, 2.5, page 177. And you guys get the privilege of problems 7 through 17. Odd.
It was 2.6.
2.6. Page 177, I'm sorry. Thank you for that, Red. 7 through 17 odd. 24, 28, 39, 41 through 44, and 53. Bet. All right, later haters. Do you guys know what time, how long the PSAT is supposed to be tomorrow?
I think
You
we're all
might
for
not
lunch.
have class tomorrow. I'm
Yeah,
not sure.
Last time,
But-
we came in by like 4th hour.
Yeah.
Okay, so we'll see where it goes. Matilda, were you able to register for the PSAT?
No.
Is it because you don't know your password and stuff?
You have to register?
Maybe not. Okay.
They don't tell us to last year when they made us do it, they didn't have us register, they just told us we were doing it.
Interesting.
Yeah.
Okay, we need to,
I'm for the college.
because SAT is also through College Board. We need to figure yours out, which it sucks, but what that's going to boil down to is you're going to have to call the College Board.
I tried one time and they didn't.
What did they say?